So that just goes to show you how wrong subjective opinions can be. But it wouldn't be a wheel review without a free hub sound check for you nonces out there. Fuck's sakes. So hi everyone, welcome back to the channel. Now, I finally got around to doing the review of the WINSPACE Hyper Disc Wheel Set that you can see on the bike behind me. Now, full disclosure, WINSPACE sent me these wheels for feedback, testing and a review if I liked them. Now, I wasn't held to do a review. I told them I would be critical and analytical and I wouldn't hold back about the wheels. So after all, that's what this channel is about, and they know that. They've been following the channel for a while, and it was actually quite endearing that they've sent these wheels to me and other independent like engineer YouTubers for basically critical analysis, because at the end of the day, if you can pass through kind of the engineering dragon's den, is there any need for like paid marketing, all that kind of bullshit? It is a bit of a risky strategy because it's an independent channel. I'm not going to hold back. You won't find any cliches here like they hold their speed or they spin up well. Well, of course they do, all wheels do. They're round, most of the weight's at the outside and they've got a bearing in the middle. So if you're reading a wheel review and it says stuff like that, just move on. Before we get into it any further, I've got a discount code for you. If you do like these wheels or you do like the look of them, they're still not like a cheap product. So I've got a discount code for you. It's in the link below. You don't have to use it, you don't have to buy them. Now, I'm not going to go into the aerodynamics of these wheels. They are 50mm deep, kind of semi-aero wheel set, but I don't have the aerodynamic testing means to put any data on anything, so anything I say about aero would all be conjecture on my part. So I'm going to focus largely on kind of the structural design, stiffness and the hub design and stuff like that, because that's where really my expertise lies. I mean, apart from having the 50mm deep rim, they're fairly narrow for modern standards, or I'd say about in the middle of the middle of the range. 19mm internal, about 25mm, 26mm externally, and they've got a low spoke count, so that's, you know, should tell you something about the aerodynamics. So first of all, let's start from the inside and basically move to the outside. Let's look at the hubs. Preload is dealt with basically fixed displacement preload. Now, what do I mean by that? Well, I mean the hubs feature tolerance shoulders and tolerance bearing seats and internal tube spacers with very finely tolerance length between the inner races of the bearings. So when everything gets clamped up in the dropouts, all the internal clearance of the bearings all get taken out by fixed displacement. Now, that's actually really hard to get that right in production and do it over and over again, and it's actually quite hard to QC because you need to have very fine control on the bearing width, so the distance between the two bearing seats, let's say, or the four bearing seats in the hub, and the internal tube spacers which go between the inner races. If, for instance, the inner tube spacers are too short, even by 10 or 20 microns, when you compress everything in the dropouts, you put too much preload on the bearings and everything kind of binds and destroys bearing life. So there are other ways to do it, much simpler ways, like for instance on a white T11 they use a sliding preload collar which you can slide in and out and then nip up with a grub screw. It's quite a neat foolproof solution because you don't rely on the internal tube spacer, and the tolerance between the two bearing seats not so important because you can take up all the slop with this sliding spacer. But it's not so much an elegant solution. It uses up a bit more axial space. There's another part, yeah, it's just a bit heavier. More difficult method is like the DT Swiss 240, is to have these very finely toleranced internal tube spacers and shoulders on the shafts of where the bearings go on, to basically take out all the clearances by fixed displacement when you clamp everything up. But it's not easy to get right, and you need very reliable and consistent production to do that. Bearings in these hubs, well, they're kind of like unbranded hybrid ceramics. When I say hybrid ceramics, I think they've got ceramic balls and steel races. Now, it wouldn't be my first choice because hybrid ceramics or ceramics are pretty bad if they get contaminated with any sort of grit. It's not really a deal breaker for me in the hubs, because if you think hubs bearings are going to last forever, then you're probably not riding enough, to be honest. You know, you could replace all of the bearings in the hub for about 25-30 quid with SKF or NTN or something like that. So I would say ride them until they feel knackered or they feel graunchy, and then put in whatever your favourite bearings are, because everyone's got their favourites, SKF, NTN, NSK, whatever. So, but the good thing about these hubs is they're really well sealed, so we'll come on to that in a minute. And the sizes of the bearings is pretty good. So you've got 6903 in the rear, which is quite a big bearing, and a 6803 in the front, which again is bigger than a lot of very lightweight hubs come with. And one really neat feature about the rear hub is they've actually used a stepped axle. So the ID of the bearing is quite big. It's quite a big bore bearing, but they've actually stepped down the axle diameter away from the bearing to just save that tiny bit of weight, and that's actually quite nice to see. Now sealing is something I'll particularly pay a lot of attention to on hubs, because it's weird how many high-end hubs you see with good bearings and nice spoke arrangement, but don't have proper sealings. So these hubs have got O-rings on both end caps on both sides, and a nice lip seal on the OD of the free hub body. Now, like I said, it's surprising how many high-end hubs literally just rely on the 2RS rubber seals of the bearings, and that's their first line of defence. And if water or grit gets in there, then you've lost your bearing. So it's nice to see the O-rings and the lip seal on the free hub. Now, the only thing I would say about the axle, like I said, it's got that stepped nature to remove a tiny bit of weight, which is a really nice feature, but it's got no like hard anodizing on it, or it's not got any hard coating. Now, a really burly hub would use a steel axle, which is nice because you want a steel axle running on a steel bearing race, because it's harder and it won't gall and it won't fret and it won't damage the axle over time. As the axle is micro bending under load, steel will last a lot longer in that surface contact. Now, a lot of high-end hubs that use aluminium axles for lightweightness use a very hard anodizing to protect that surface under the bearing race. I think if you take apart a DT240, I think the axle has a very hard black anodizing, although it's aluminium, to protect it in the bearing race. These hubs don't have any of that coating, it's basically just raw aluminium, but I think from testing the press fit, they're quite hard press fit on the inner race as well, so that should prevent the galling, fretting and under rotation that might damage an aluminium axle. Now when you take a look at the hubs, so the hub bodies themselves, well, they're quite impressive, and the level of machining around the spoke holes on the hub for the straight pull spokes is very intricate, and actually it's quite alarming how little material there is, and they've done that to save weight basically, but it's actually very hard to machine very lightweight hub shells with high tension radial spokes. Like on front and rear on this, on the front and rear hubs of this wheel set, one side is radial. Now when you've got very high tension radial spokes, what that can actually do is, let's say you have an M7 interference bearing seat tolerance on the outer race of the bearing where you press fit your bearing in. If you then have, let's say, 7 radial spokes with 110 kilos of tension in each one, when you tension them all up, that's 770 kilos of radial force pulling that bearing seat out, and actually pull the bearing seat out of tolerance. And that's quite hard to get right if you're making very lightweight hubs with radial spokes. There are a number of ways you can get around it. It's either like mechanically decoupling the spoke tension from the bearing seat, but that requires a bit more material and kind of some clever FEA or kind of structural analysis. Or you can do basically an empirical machining process, which is where you machine the bore slightly too small for the bearing, or the bearing seat slightly too small, so that when the spokes are tensioned up, it's then at the right fit. And you would test that by trial and error empirically, which I think is probably how a lot of hub manufacturers do it. Or you can do something called pre-stressed machining, which is, well, I wouldn't say it's common, but you can. Last time I saw it was in F1, like Cosworth. You have a very high tolerance engine components are stressed on a machining jig as they would be in an engine, so they fit together with very, very high tolerances, and you basically end up with a final machine part that's had the deformation put into it whilst it's being machined. Now you could do that with a hub. I mean, it'd be an expensive jig and an expensive fixture to do that, but if you created the hub shell on the milling machine with the tension, with the spokes in tension all the way around the outside, so when you did the final milling of the bearing seat, it was at the right tolerance, and then when you release the tension of the jig, it actually came in slightly. Now, I don't know how WINSPACE are doing it, but and I haven't actually tested the bearing seat tolerance, but this is the kind of level of detail that these very lightweight hubs have to have done to create the product, because there's so little material around the bearing seats on these lightweight hubs these days that it's very easy for the spoke tension to pull the hub shell and the bearing seat out of tolerance. Now the spoke arrangement and angles of the spokes, like I said, there's 21 front and rear, which is quite low, especially for me. I'm quite heavy, like 90 odd kilos. Haven't had a problem yet. But one thing you need to check is the spoke angle on the non-disc side on the front wheel is extremely wide, and that flange is very wide out towards the dropout of the fork. And you need to check this very carefully before if you do want to order these wheels, that hub flange and the spoke heads are actually going to clear the fork leg. Like I'll drop in the little video of mine here on the TCR disc. It is very close, and WINSPACE do say on the website you need to check your fork, but it would be actually really helpful if they provided a drawing or some actual dimensions and tolerances, so you can actually maybe print something off and cut it out and put it in that gap to see if they fit, because it would be pretty disappointing if you bought the wheel set and they didn't clear the fork. And I would say the TCR fork legs are pretty slender, and it's still very close. So if you're in doubt, it's probably worth trying to contact them and ask, because or they should at least have some kind of guide on the website, or some dimension drawing to help you. Massive bracing angle on that side, as we'll see in a bit, does add to the massive out of plane stiffness of these wheels, which I was quite surprised about. Now, like I said, on both front and rear there is one side with radial spoke arrangement, and on that side they're only using 7 spokes, whereas there's 14 on the tangential side. Now, at first that might seem a bit odd, but the good thing about using only 7 on the radial side, where that spacing is a lot wider, is that you can increase those spoke tensions and still have a properly dished wheel. Because if you have, let's say, 12 and 12 spokes on either side, and then one side has a much wider bracing angle, you have to drop the tension of those 12 spokes on that side to keep the dish true. Whereas if you only use 7 spokes on that side with the wider bracing angle, because they have a higher basically horizontal force component pulling the wheel to that side, if you have less of them, you can put each one in higher tension. So that means the tension is more balanced between the left and the right side of the wheel, even though there's only 7 on one side. So that's quite a nice feature. Now, one thing that did alarm me slightly is there's only radial spokes on the disc side on the back wheel. Now, on the disc side is where you're getting the braking torque, and the radial spokes on the back wheel, or radial spokes really can't react to torque. They're not tangential, so they can't do any kind of like pulling to the rim. So the load path, and when you apply the brakes on the back wheel, will have to go through the hub body to the trailing spokes on the other side, on the drive side. And it's the drive side on the back wheel that does the torque transfer from the cassette, so the acceleration and the braking. So you've got the 2 crossed spokes on the other side of the disc that are doing braking and torque transfer. Now, on the front wheel, your crossed spokes are on the disc side, and then the radial ones are on the other side, which is kind of nicer. But again, you've got 7 radial spokes on the non-disc side. On the disc side, you've got 14 spokes. But don't forget, only half of those 14 spokes actually do any braking, because only half of them are tangential going back from the braking torque. And although they're all in tension, when you apply the brakes, you get a braking torque which creates a higher tension in 7 of the trailing spokes, and a slightly detension in the leading spokes. Now, when I first got these, I thought, wow, only 7 spokes doing all that braking from a big 160mm rotor on this bike. And when you lock the front brake and you rock the bike back and forward, you can actually feel that slight torsional spring of the front wheel. Whereas if you compare it to my light bicycle build with the tuned hubs, I did 24 holes, 2 crossed both sides. So I've got 12 spokes doing the braking torque on this wheel, and I've only got 7 doing the braking torque on the WINSPACE. Now, you can actually feel that statically if you lock the brake on the floor while you're not moving and rock the bike back and forward. You can actually feel that slight torsional wind up of the wheel. But that will actually help in wet, and particularly wet and bumpy roads. That will help. Having that extra torsional spring in the middle of the wheel will help. A bit of modulation should increase the braking modulation a little bit, but actually, when you're going along, you can't really feel the stiffness difference dynamically. You can only really feel it statically if you rock the bike back and forward. And it's basically just to do with there's just basically half the spokes on these wheels doing the braking, as you would if you had 2 crossed both sides. Now, the spokes. This is one of the main points of interest for me about these wheels, is that the spokes are carbon spokes like you see on the KDEX wheels or some of the Hunt wheels. Now, spokes are actually a really nice thing to use with carbon fibre, because spokes are almost always purely in tension. They're not really strong enough to resist any bending loads, and although they do have relative compression in them, they're always pre-tensioned. So a spoke is only really seeing tensile load at any time, basically. So UD carbon is really nice for that, because carbon it was always best in pure tension. That's where its highest tensile modulus lies. If you start using carbon off axis to the main direction of the fibres, you're really not using it at its full potential. So carbon fibre spoke is a really nice thing to do if you can do it properly. But I'm quite sceptical about these spokes, is because they have a threaded nipple on the end, and how is that nipple bonded to the spoke? Now, WINSPACE and KDEX and these companies are claiming that the ultimate tensile strength is coming from the carbon spoke, but if you've then got a bonded threaded aluminium nipple on top, the ultimate tensile strength of the spoke will be the max shear strength of the epoxy holding the nipple on. So I've asked WINSPACE, like, how's this claim true? Are they actually, if you put the spoke system, so including the nipple and the threaded part, the bonded part, into a tensile test rig, what would fail first? And I would be surprised if it wasn't the nipple, but I'm yet to be proven wrong because I'm waiting for their data. But maybe there's some proprietary technique of assembly which maybe like loops the spoke through like an eyelet at the top and then it's bonded. But I don't know how they can claim it's the tensile strength of the spoke when presumably, I'm not sure, but presumably the nipple is bonded on. But that's just conjecture at the moment. The rim, well, it's black, it's round, it looks pretty well made. I'm not going to cut it up to get inside it and have a look because I'm riding them. There's not much more I can say about that. The weight is claimed at 1,425 grams for the pair for a disc wheel set, and that's pretty impressive. I think they are tubeless ready, but they are hooked, so they're not hookless, so they're tubeless ready. You need rim tape, and they do have a hooked bead, which I particularly like because I will ride them with clinchers and tubes. I won't use them tubeless. Now the stiffness is something I did test in my lab, and I tested them against 4 other wheel sets: the Light Bicycle Tune and DT combo that I built up, my Far Sports Dura Ace and Bitex rim wheels, and what else did I test? Some aluminium wheels as well. So we'll have a look at that test setup. So welcome to the lab, everyone. This is the quick test setup that I'm using to test the outer plane stiffness of each wheel. First of all, I'm going to benchmark the Light Bicycle wheels that I've built, which I think are very stiff. This has got 24 holes. This is the front wheel. The rear has got 28 spokes, and I think that's really stiff. So before I test the WINSPACE ones, I'm going to test the Light Bicycle build to get a bit of a benchmark. Now, I'm clamping the hub as it would be clamped in the fork with the same torque or the same axial load, and I can adjust the axial load by changing the torque on these bolts which are clamping down on the hub. As long as I keep that fairly consistent between the two tests, it should be relatively good. And I'll put the dial gauge on the bench in the same position on the two tests, because when I add weight to the edge of the wheel here, it will actually pull the skin of the table slightly, and even though the dial gauge is mounted over there, it will affect that. But as long as I keep it the same in both tests, the table deflection should be fairly well cancelled out. You can see how sensitive this setup is, and I'm literally putting hundreds of grams on the edge of that rim, and you can see the axial deflection in the wheel. I might have to change this dial gauge for a less sensitive one. So the rear wheel now, changed the test setup a little bit, different dial indicator, a bit less sensitive to measure bigger deflections. This wheel's got 28 spokes on the Light Bicycle 65mm rim, DT Swiss 240 hub, and I'm getting about the same deflection on the rear as the front wheel for the same load. Now that's unusual because normally rear wheels are less stiff because of the narrower bracing angle of the spokes, but because I've increased the spoke count on this rear wheel, it's 28, I've got some stiffness back. So this front wheel and rear wheel set is really well matched. I've got 24 on the front, 28 on the rear on the Light Bicycles, and I've basically got the same stiffness in newtons per millimetre front and rear, so it's quite well matched. So let's see how the others get on. Now for the WINSPACE Hypers, I've let the air out the tyre, so that doesn't have an effect on stiffness, because I've tested the others with no tyre on, so I've let all the air out so it doesn't change the spoke stiffness or anything, or the spoke tension. Got the dial gauge set up, I'm going to apply the same load and see what we get. Actually now I've fixed them to the table, just by deflecting by hand they feel stiffer, and that goes against what I said originally, but they do feel stiffer than the other wheels. So let's have a look.
I did turn this one.
Yeah.
I don't know whether that made it work.
Probably not. If there was no load on it, it probably wouldn't affect it.
Yeah, it's ready.
just for reference, watch what happens when I load an aluminium rim with long steel spokes in the same test, the same load. Now each rev on the dial gauge is 1mm downwards. 10 kilos, 100 newtons. So that's fully loaded. I'm going to take the load off and count the number of revs. 1, 2, 3, 3.5. WINSPACE Hypers were 2. So they're nearly twice as stiff. Super impressive actually, stiffer than I thought they were. So I'll put all the results up in a table, which I'll put in the video. All the wheels I've just tested. But out of all the wheels I've just tested, these are the stiffest. So the WINSPACE were the stiffest out of all the wheels I tested in the lab. And I didn't see that coming, and I put that down to basically the massive bracing angle of the radial spokes, the 7 radial spokes, and the higher tensile modulus of the carbon spokes, and their relatively short spokes as well. And it wasn't, you know, night and day improvement on stiffness on the other wheel sets, but pretty promising actually to see that the material properties they're claiming did lead to a stiffer wheel. Now I'm not saying a stiffer laterally wheel is better, who am I to say, because when you're leaning the bike over in a corner, if you get a vertical input from a bump in the road, it is nice to have a bit of lateral flex in the wheel. If there's no lateral flex in the wheel, you're going to transmit a very high dynamic force into the frame, which could throw you or could lose grip of the tyre. So a slightly compliant wheel laterally is nice, but I don't know what the magic figure is. It's all dependent on feel. And actually, if you look at the aluminium rims which I tested, the H+ Sun archetypes and the SAP MCX Ray spokes, which are very long spokes, which will have a higher unit stretch. Sorry, they will have a higher total stretch, not unit stretch. Now the same unit stretch because they're the same spoke, but they'll have a higher total stretch. And actually, it was amazing to see how compliant they were under the same load compared to the deeper carbon rim. But anyway, I hope you enjoyed this independent review of the WINSPACE Hyper disc wheel set. I've really enjoyed riding them so far, and I'm genuinely quite impressed by the product, and I'm also impressed by the company, because they've been really the first company that's approached this channel has been willing to undergo kind of a public grilling or a public review where I didn't hold back, and yeah, I'm quite impressed by them. And I really hope more companies realise that you can't just pay for paid reviews anymore, because it is massively patronising to you and me to watch these paid ads. But if you like the look of them, then discount codes in the description. I'll update if anything goes wrong.